Hi all, this is Dr. Shanthi, Professor, ECE Department, RMK College of Engineering and Technology. In this presentation, we are going to explore the usage of virtual labs. And as an example of usage of virtual labs, I am going to show you how to implement a half adder. Now, the link for going for virtual labs is https://www.virtuallabs.co.in. Now, when I click on this link, you will have a list of IITs offering the virtual labs, IISc also. Now, I am selecting the virtual lab of IIT Guwahati, right? So when I click this link, it will automatically go to IIT Guwahati. Okay, right. Next, on clicking this link, the screen that is will open is you will get a screen of this form, and here you have to select the Digital Electronics Lab 2. When I click on the digital electronics link of IIT Guwahati, the screen that will open will be of this sort. Okay, right now when you look into the screen, to the left you have an introduction, objective, list of experiments, target audience, course alignment and feedback. Now what I will do is, to the left I go on to list of experiments. When I click on the list of experiments, a menu will be displayed here. See, the name is Digital Electronics Lab and the list of experiments that can be done is shown here. To implement a half adder and full adder, parallel binary adder, BCT to 7 segment, BCT to gray. So you have a list of experiments that can be done. In the list of experiments, I had selected the first one, implement of half adder, right? So when I click that, and a screen of this sort will open, right? Now what I'm going to do is, we are going to implement a half adder, and you will have a menu left side like this, right? Aim, theory, pretest, procedure, simulation, post-test, references and feedback, right? Now you will get this sort of window, right? Now we have to go on how to implement this half adder. For this, you have to know what is the theory behind half adder. Now when you look into the theory that is present here for a half adder, you're going to have two inputs. The two inputs here is A and B, and there are two outputs, S standing for sum and the C standing for carry. Now look at, if I have two inputs, you all know you will have four combinations, 0, 0, 0, 1, 1, 0 and 1, 1. Now when I'm Boolean addition, 0, 0 is 0, 0, 1 is 1, 1, 0 is 1, and for 1, 1 it is 0, right? Now that is for C. What is C? C is going to be carry. For A 0, 0 it is 0, for 0, 1 it is 0, for 1, 0 it is 0, and for 1, 1 it is 1, right? Now when you look that is values for sum for various combinations of A and B, it resembles that of an XOR gate. In the same way, when you look into the carry output for the two inputs A and B, you can see that it resembles that of an AND gate. Okay, so what will be your diagram? The two inputs A and B, you give it to an XOR gate. The output what you get from the XOR gate represents the sum, and the two inputs you give to a NOT gate, AND gate, and the output what you get is a carry, right? So this is going to be XOR gate and this is going to be an AND gate. Okay. Now to the left, if you click on the procedure tab, you will get a screen of this sort, right? Now what are the two gates you require? You require an AND gate, you require an XOR gate. So IC 7408 is the AND gate and IC 7486 is the XOR gate. Okay. right? And now how to make the connection they have given, right? Now I'll show you in the next slide, right? Now how to give plus VCC, that is supply, how to give ground, all that they have told here, right? And that is how to make connections, all that is given here, right? Next is how to run. Green LEDs represent logic 0, red LEDs represents logic 1. We have to connect to VCC and ground pins of the ICs and the power supply. Okay, right. Now this is I should click the simulation button on left side. Now when I click the simulation button, a screen of this sort will appear, right? Now this is very clearly showing me how the breadboard will look like. Now you all know the breadboard, and you all know these connections. The red line showing there all is in series. Okay, the first line is in series fully, the second line is once again in series. In the same way, the top blue line, all the first row slots are in series and the second slots are in series, right? And here you have a power button and here you have a ground button. Okay, right. Next is you have input switches, right? Input switches is the green color indicates that it is logic 0, and these are going to be output LEDs. If they are in green color, that is as we have seen, A and B are representing inputs, sum and carry are going to represent outputs. Okay, right. Now these two are nothing but the pin diagrams. So this is the pin diagram of XOR gate, which means that pin 1, 2 can be given as inputs and 3 is taken as output. As usual for any other IC, 7 is ground and 14 is VCC. So 4, 5 can be given as input, 6 can be taken as output, right? And in the same way, this is an AND gate and 7408. So 1, 2 can be given as input and 3 can be taken as output. 7th pin is connected to ground and 14th pin is connected to VCC. Right. Now let us see how to give connections. I have given connections. You can go and do it in the website that is in the virtual lab site that is following this video. See here, you have to click here. You have to click here, and when I drag a wire and place it here. So this is the VCC connection. So which means that this full top row I've used as VCC, and this line is the ground line. I have taken it to the bottom of it, right? So this first top row is the ground line, right? Now I have placed two ICs, right? One is going to be the XOR gate, and this is going to be what is that, AND gate, right? Now from where you will select this is, you have to go click on the components. When you click on the components, you will get the ICs. That is, when I click on this component window tab, I'll get the two ICs. I have to place the ICs like this, right? Next, what I have done is that is input switches are there, right? You all know pin number 1 and 2 are input connections. So I have given pin number 1 and 2 to this input switches, and pin number 3 is the output, which I have given to sum. The first is an XOR gate, which means that 1 and 2 are inputs, and the third pin is the output, which is the sum, right? And here look at the 14th pin. 14th pin is connected to VCC. The 7th pin is grounded. In the same way here, 14th pin is connected to VCC and 7th pin is grounded. And this is a AND gate. Inputs are given from 1 and 2, and the carry output is taken from the pin number 3, and it is connected to the output LED. Okay. Then once I give the connections, I have to press start. Okay. Right. Now what I have done in this slide is, I have in the earlier slide, as I told you, green represents logic 0 and red represents logic 1. Now look at the switch now. Input switches, A is 0, B is 1. Right. So when A is 0 and B is 1, what should be sum? Sum will become 1. Right. Carry is remaining unchanged. Right. So when I give start, I'll get an output of this sort. Okay. So for 0, 1, the output sum is 1 and carry is 0. Now look into the input combination. Now A input is 1 and B is 0. Now for this, once again, sum is 1 and carry is 0. Right? Now once I give the input switches, I have to click on the start button. So I'll have the output displayed. Now look at the final combination when both the inputs are high. As I told you, red indicates high, right? When both the inputs are high. Now what is the output? Sum is 0 and carry is 1, right? So 0, 0 means sum is 0 and carry is 1, and hence the truth table of half adder is verified. So before you are coming to the lab, you can run the simulation in virtual labs and come, so that it will be very easy for you to implement in the labs. Thank you, students.